Hello and welcome to the TTI Distribution Download, the podcast where we talk about all things happening in the world of electronic components with the specialists of TTI. And now, your host for the TTI Distribution Download, Paula Renfrow.
Thanks, Jim, and hey, everybody, thanks for plugging in to our third episode of the TTI Distribution Download, where we're joined by our partners from YAGEO, and we're talking about artificial intelligence. In Episode 3, we welcome back Dr. Philip Lessner, Executive Vice President and Chief Technology Officer for YAGEO Group.
Hello again, Paula.
And we invite back also Mark Lapps, Technical Product Manager of Ceramic Product Business Unit.
Hello again.
Thanks for hanging in here with us. So today we're going to talk about artificial intelligent component solutions, right? So let's kick off with what are the specific product developments YAGEO is working on to meet the challenges of AI?
So I was reading a good article last week called Powering the AI Revolution by Adam Fleischer. And this had to do with the importance of the electronic components industry supporting the transformative impact of AI and machine learning. And he said, and I quote, "The electronics component industry is not just an enabler, but the very backbone of this AI and machine learning era. By continuously innovating and adapting, the industry nurtures the growth and evolution of AI and machine learning." Now, there's many types of components that make up an AI system, but passives such as capacitors, inductors, resistors, sensors, they all definitely fall under this category. So when you look at YAGEO's portfolio, we have a very broad range of components that address the challenges of AI systems that we talked about in the previous podcast. So just to highlight a few, when we talk about Class 1 MLCCs, we are an industry leader in Class 1 dielectric development, both in C0G and U2J dielectrics that support resonant applications for wide bandgap-based power converters that operate at very high efficiency. So for these capacitor solutions, these designers need capacitors that have ultra-stable capacitance with voltage and temperature, and they can handle high AC voltages and or high AC currents with very low self-heating. This means they need capacitors with very low ESR, low dissipation factor. So YAGEO offers a wide range of Class 1 C0G and U2J MLCCs utilizing our calcium zirconate dielectric technology. Now, what that means is these capacitors have excellent capacitance stability with both temperature and voltage. It also means they have very low ESR and dissipation factor, and this results in minimum self-heating and power loss under the high AC voltages and currents. So in addition, we have our Connect technology. Now that's Connect with a K, so it's KONNEKT. And this is where designers are looking for more power in a smaller footprint. So we developed Connect, which is a high-density packaging technology that combines multiple MLCCs using a transient liquid phase sintering process. Now this is a fancy way of saying we're connecting multiple MLCCs together using a strong conductive material without the use of metal frames. So with this technology, we can get more capacitance in the same footprint. It also has the unique capability of mounting in what we call low loss orientation. So that's when the MLCCs in the stack are perpendicular to the PCB. What this does is drastically reduces the ESR of the capacitor, as well as minimizes the thermal resistance to the PCB. Now the effect of this is it reduces the overall self-heating and allows for very high AC currents. Now, we've been able to combine our Connect technology with our Class 1 C0G and U2J dielectrics, along with our KC Link product line to cover a very wide range of applications, from 48-volt servers to EV onboard chargers and DC fast chargers. We've also implemented Connect with our Class 2 X7R dielectrics, which allows for higher capacitance without increasing the footprint on the PCB. So this allows for more bulk capacitance. So another important factor for AI applications is RoHS compliance. So Connect technology, Class 1, C0G, and U2J, all completely lead-free and RoHS compliant without exemption. Another area is, we're continuing to invest heavily in high CV MLCCs, which are ceramic capacitors that have the highest capacitance and the smallest K size for decoupling applications. Now, these are typically X7R, X7S, X6S dielectrics. This development is critical for AI applications since these processors are very powerful and running at high speeds, which needs MLCCs as close to the load as possible to reduce those parasitic effects. In addition, we have a joint development agreement with Smoltek from Sweden, who is a carbon nanofiber technology leader and is developing and commercializing ultra-thin carbon nanofiber capacitors that can be mounted under processors and microcontrollers. Now, the goal of this technology is to bring decoupling capacitors as close to the processor as possible to reduce parasitic effects for high-speed decoupling. So they're also exploring the possibility of attaching these capacitors directly to on-chip carriers or bump them directly on the die to further drive down those parasitics. So we're very excited about new technologies such as this and already engaging with lead user customers for AI applications.
Yeah, Mark, thanks. Let me talk about some other components that YAGEO Group is developing. So we have a broad portfolio of tantalum and aluminum polymer products, and in fact, YAGEO Group is the number one supplier of tantalum polymer in the world. These components are used both in the servers and also in edge AI applications, primarily for bulk decoupling. Now, polymer technology for tantalum and aluminum capacitors is a technology that's evolved in the last 20 or 25 years or so, replacing the older cathode technologies like manganese dioxide and wet electrolytes for aluminum electrolytics. The advantages of polymer technology are much lower ESR and also benign failure modes and very high reliability. And those are all very desirable characteristics for the AI systems. So we have these components. We continue to drive ESR down, also ESL. We continue to work on new packaging technologies that are decreasing the ESL of the components. And also another trend that I'd like to mention within these component families, and in fact, within all the component families that we develop, is the trend toward higher voltages. So as Peter and Mark have mentioned, the power of these AI servers is much greater than the standard servers in your data center. So the current in between the racks is much higher. So there's a trend to go from 12 volts to 48 volts for distribution of the power, and that means higher voltage components. So we're developing 50 volt, 63 volt, and 75 volt components to meet these new power distribution needs. So that's a little bit on the capacitor side. Then to switch to talking about inductors, we're developing also new materials for inductors, and we have an exciting new material called nanomet. So that's a nanocrystalline type of iron material that's used as an inductor core. And the advantage of nanomet is it combines some of the best properties of ferrite-based inductors with some of the best properties of metal composite-type inductors. So with ferrite-type inductors, you have a very low core loss, but you pay for it sort of in the fact that the stability of inductance with temperature is not so good, and also there's a sharp decrease in inductance above a certain current density. On the other hand, metal inductors have a higher core loss than ferrites, but they have much more stable current and temperature characteristics. Our nanomet material combines the best characteristics of both the ferrites and the metal-based inductors, so it has a fairly low core loss, and it also has the good temperature and current stability properties. So we're excited about this material. It's starting already to see applications in some AI systems. We're working with some OEM manufacturers to implement it right now in some power delivery systems. And we believe this will be a material that brings us into the next generation of inductors.
Dr. Lessner, let me ask you this question. How does YAGEO see the next generation of these components that we were just talking about meeting the needs of AI hardware?
As Mark mentioned, one of the next generation needs is moving the components closer to the processor. So he mentioned the high CV MLCCs and also the Smoltek partnership that we have. But that also holds for inductors. So with our development of our nanomet inductors, those actually have somewhat higher permeability than the standard metal inductors. So we're able to actually shrink the footprint of those inductors and therefore move them closer to the die. So if you shrink, for example, the height, that gives you more opportunities to place the inductor closer to the die, for example, underneath the semiconductor. So closer to the die is one important aspect of the next generation. Another important aspect is miniaturization. And that's related to closer to the die, but also is somewhat separate from it in the sense that you need miniaturization in order to pack the electronics closer together. So the density of electronics in the data center is increasing, and miniaturization plays into that. But the other area for miniaturization is really AI at the edge. So that's AI in IoT applications and applications like advanced driver assist and autonomous vehicles. There, space is much more limited, and miniaturization is not only a nice feature to have, but it's really an enabling technology to bring those applications forward. And then the last area, and we've touched on this several times already, is ultra-low parasitic. So we continue to advance the component design and material science to move to ultra-low parasitics to help the stability of the power delivery networks, and also the thermal characteristics of the components. We're using not only experimental design tools to develop components to reduce these parasitics, but we also use computer-aided modeling tools like, for example, the ANSYS computer-aided design packages to do advanced thermal and electrical models, sometimes simultaneous thermal and electrical model, in order to accelerate the design of our components and also provide advanced information to our customers with our E2DI philosophy.
E2DI, easy to design in philosophy. Mark, tell us a little bit about that, and why does it matter to the design engineer?
Yeah, so E2DI, again, stands for easy to design in. And this is based on the concept that when we talk to customers, we don't like to just think of ourselves as just another component supplier. In many of these leading-edge applications, we're trying to help our customers solve a problem that doesn't necessarily have an easy answer. So that can mean special design and modeling tools, design services, technical content, or just basic personal engagement. So when we work with customers, we like to think of YAGEO as providing solutions. So E2DI achieves this through things like technical content, tools, and services, all with the aim of eliminating barriers between the design engineer and a solution. So when we look at the evolution of technology, as Peter was mentioning earlier, there's one thing that's pretty clear with design cycle time, and that is design cycle times are decreasing. And this is in almost every industry. So the push to get AI products to the market faster is accelerating, and designers need content and tools to better equip them in designing in components. So take an example, a power designer needing a decoupling capacitor for a leading edge application. They have design targets that they need to meet with impedance, ESR, ESL. They may need spec sheets, simulation data, and models. Now, historically, data sheets have very little information, and getting that information from suppliers can take time. So if this information is not readily available to the designer, it acts as a barrier to the design-in process and slows down that design cycle time. So E2DI looks to eliminate as many of those barriers as possible for the AI design engineer. We don't want there to be any barriers in selecting and qualifying components in their system. So when you take a step back and look at E2DI, there's multiple elements. In its simplest form, it contains things like data sheets, quality documents, and technical literature. This is kind of the base level E2DI, which most suppliers are going to have. But then you need things like rapid sampling. So we need to make sure that we have stock and distribution. Whenever we get products out there, we want designers to have easy access and be able to get samples within 24 hours. So we have full component simulation. So we have online tools such as KSIM, where you can simulate characteristics of capacitors such as ceramic, film, tantalum, and aluminum electrolytic. We have film lifetime modeling capability, inductor simulation. And then you have things like custom test support. So we have advanced test labs at our facilities where we can help designers run specialized test and specialized characterization of parts that are kind of beyond what you would find in a tool. So they want to know how our parts operate under their conditions. We can bring our parts into the lab and test them under their application conditions to help them understand its performance.
So how does an engineer take advantage of this service?
You know, we have ways of contacting YAGEO through our sales department. They can request what we call an RTI process. So they can request, by submitting their application conditions, and we can evaluate their applications and see if we can answer it using our online tools. our expertise, any data that we currently have, or if the application's beyond what we already have, we can take that part into the lab and run some advanced characterization. So you think of a scenario where an application engineer is using a switch tank converter and operating MLCCs at very high AC currents. They need help to understand how those components operate under their conditions. So we can take those parts and run them in our labs to help understand what kind of thermal effect it has on our parts, things like that. And then you have application experts. So, I call these our boots on the ground, our field application engineers, being able to get next to that design engineer and help them match their problem with a YAGEO solution. And then ultimately, we want advanced simulation tools. So we're working on tools now that, usually when a designer comes to a supplier, they have a part number and they want to find the characteristics. But we want to reverse that. We want a designer to come to YAGEO with their application conditions and use our advanced design tools to return back a part number. And that's something that's a little bit more unique. There's many different components out there, especially when you think about capacitors, many different technologies. And one technology may be better than another one for specific application under their conditions. But they might not know which specific technology to use in their application. And even when they know what technology they need, they may not know what particular part number to use. So being able to come to YAGEO with their application conditions and use an advanced design tool to put in their application conditions and receive back a part number with the characteristics is kind of that ultimate advanced simulation tool. So E2DI is this total package of content, tools, and services that we believe is absolutely necessary for these artificial intelligence design engineers to make significant advancements in this space.
And that's a wrap, listeners, on our series covering artificial intelligence with our partners at YAGEO. Thank you, Dr. Lessner, and thank you, Mark. And I want to recognize again and thank Peter Blaze, who joined us in episode 2. And remind our listeners to read Dr. Lessner's article, Advancing Artificial Intelligence, YAGEO's Role in Powering the AI Revolution. And you can read that article at tti.com/marketeye. Thanks for plugging in.
Thank you.
Thank you.
That's it for this episode of the TTI Distribution Download. For more information on any of the topics you heard about today, reach out to your nearby TTI branch at 1-800-CALL-TTI or visit us online at tti.com.